Hello everyone. In this session of CCNA series, we'll discuss STP protection mechanisms, BPDU guard and BPDU filter. Before we go ahead and discuss about those two features, let's have a quick overview of what STP is. STP, also known as Spanning Tree Protocol, is a network protocol designed to prevent loops in Ethernet networks. It works by creating a loop-free logical topology, ensuring that there is only one active path between any two network devices. So why is STP important? So without STP, redundant paths in a network could create loops, leading to broadcast storms and network instability, which can severely degrade network performance. So why there is a need for STP protection? While STP is effective at preventing loops, certain situations can still cause issues. For example, a misconfigured device or an unauthorized connection could disrupt the STP topology and cause network problems. So why protection is required? STP protection mechanisms are needed to address these potential vulnerabilities and to ensure that the network remains stable and secure, even in the face of unexpected events. So these protections are designed to prevent potential issues such as network loops, topology changes, or security vulnerabilities that could disrupt network operations. So with that, there are few STP protection mechanisms such as BPDU guard, root guard, loop guard, and BPDU filter. So we'll discuss about BPDU guard and BPDU filter in this session, and the remaining two will be discussed in next session. So before we discuss about BPDU guard, let me tell you, in the previous video we discussed about port fast, right? So it's a feature of the STP that allows a switch port to immediately transition to the forwarding state by passing the usual STP state, that is listening and learning. So port fast is typically enabled on those access ports where end devices are connected, but it creates an exposure. For example, if someone accidentally connects a switch to one of these port fast enabled ports, the switch might start sending BPDUs, right? Which could cause unintended changes in the STP topology and potentially create loops. So BPDU guard is a security feature in the STP designed to protect network by preventing unwanted STP configuration or loops. So it protects the network from malicious user by devices by blocking BPDUs on edge port, that is access ports. So basically, I would say it monitors your port for BPDUs, and if it sees one, it shuts down the port. That is, it puts the port in error disabled state. So by enabling BPDU guard on those ports, port fast enabled ports, you ensure that if any BPDUs are received, the port will immediately be disabled, protecting the network from possible disruptions. So using port fast without protection is always a loop, and using BPDU guard on those ports makes sense, right? Because if another switch connects to that port, the local switch can disable the port to prevent any further loop. So the next protection mechanism is BPDU filter. It is a security feature used in Ethernet network to control the sending and receiving of BPDUs on switch ports. It is primarily used to prevent certain ports from participating in the STP by filtering out BPDUs. It is extremely useful on those ports which are configured as port fast ports, as there is no need to send or receive any BPDU messages on those ports. So the spanning tree BPDU filter works similar to BPDU guard, as it allows you to block malicious BPDUs. The only difference is that BPDU guard will put the interfaces that receives the BPDU in error disable mode, while BPDU filter just filters it. In simple term, I would say BPDU guard acts like a bodyguard fighting off threats, while BPDU filter functions more like a locked door, barring entry for any unwanted visitors. So BPDU filter feature defines two functions under one name feature. One is BPDU filter to prevent loops on port fast ports, and BPDU filter to disable STP on a port. So when you enable port fast on access ports where end user devices like PCs connected, you risk someone unplugging those devices and replacing them with switches. And you could risk a loop by connecting those switches. If you see the switch, two ports use port fast, but the endpoints were replaced with two rogue switches. And BPDU, if you don't have BPDU filter, it will create a loop, right? So when you have a BPDU filter, it reacts by disabling the port fast on that port. The port then reverts to normal STP rules. And the port will start running STP and may block or forward depending on the result of that normal STP logic. So this is how BPDU filter works, and you can enable this by using global command, that is spanning tree port fast BPDU filter default. BPDU filter monitors to notice any incoming BPDUs, and if I want to explain this in 3 steps, how I would explain is it monitors to notice any incoming BPDUs, and if they begin to arrive, first what it does is it disables port fast on that port. Then it reverts the port to use STP with normal STP rules, right? And then to protect against such a case, you can use either BPDU guard or BPDU filter. It's your choice. Another function is BPDU filter to disable STP on that port. So the BPDU filter feature can be configured to enable completely different style of logic. However, when enabled with an interface subcommand, the previous one we enable globally, right? This one you can enable under the interface. It does what just the name says. It filters all the BPDUs on that port, both outgoing and incoming. If you see in the topology, if you have two firms, right, and if you don't want these two firms not to participate in the STP setup, so you can just enable BPDU filter where it will completely stop both incoming and outgoing BPDUs. Using this filter is very risky because it effectively disables STP on that port. This feature is really risky. Do not use it under production network unless you have thoroughly tested and understood what it can cause. As I said, you can enable it when two departments develop network inside the same firm and they want to connect, but they do not want the other department network STP to influence there. So in that situation, you can use it. And to do so, they filter, as I said, they filter all the BPDUs between those two network by basically disabling STP on those links. That's it for this session. I hope this was informative.